Hi, my name's Tyler Compton, and you're watching the 7th episode of Gaming and Go. So, in this episode, we're going to be tackling the concept of character animation in 2D video games. So before we get started, let's talk a little bit about how animation usually works in the concept of these 2D games. Generally, people use what's called sprite sheet animation. And sprite sheet animation is the concept of playing multiple frames of an animation one after another to create the illusion of smaller movements within a character. So to demonstrate this in our game, I've gone ahead and prepared some frames of animation myself. So you can see we've got the old basic enemy here, but we're going to be animating that. So I've created a basic enemy directory, and in here you can see there's an idle directory and a destroy directory. And in here you can see that there are some frames of animation. So for idle, we're simply having the enemy flap its wings to, I guess, stay in the air. And in destroy, we're having the enemy explode. So I think you can see, when these animations would happen, and it should help our game look a little bit more dynamic, right? I mean, when you play the game right now, if we just go ahead and compile what we have, it's a very static experience, right? Unless you press a key, nothing really happens. And even when you do, the spaceship is just sliding back and forth. And when you kill an enemy, they just kind of disappear. There's no feedback, right? It's not very satisfying. So let's see what we can do about that. Let's take a look at the basic enemy as we have it right now. We start by creating a sprite renderer component, which is able to render just a single image on screen, and that's about it as far as our image rendering pipeline is concerned for the basic enemy. If we want to add some animation, then we're going to have to create a new component that is able to display frames one after another and handle all the intricacies associated with animation, not just displaying a single frame. So let's create a new component called Animator, and we'll create it inside of a new file, fittingly named animator.go. So if we create a new type called Animator, we'll have it hold the element that it is attached to, which we've called container, and we've done this for every other component that we've designed. And so it's just a reference to, in this case, if we're attached to a basic enemy, the basic enemy element, and we'll see why that's important later. And then we need some way for the animator to hold information on the animations it's going to play. I want a single animator component to be able to play all animations that the object needs, or the element needs. And so what would you call a single kind of animation, like the destroy or idle animation? I would call it a sequence, because it's a sequence of image frames. So I can see the animator having a field called sequences, which is a map. And it will have a string, which will be the name of the animation sequence to play, and a pointer to a sequence object. And a sequence object will contain all of the information for that specific animation sequence. So let's go ahead and define a sequence type. So a sequence will need to be able to hold all of the images all the image frames that it's going to display. And if you recall, we hold those as SDL textures. So let's just create a field called textures, which is a list of SDL texture objects. Then we need a way of holding the current frame, the frame that is on display right now. And we'll call that frame, and it will just be an int that indexes this list. Then we're going to need some way to describe to our animation system how quickly the animation should play. And there's lots of different ways to do this, but we're going to use what Unity calls a sample rate. And let's make the sample rate a floating point value. And what that is the number of frames that should be, or the number of times the frame should be incremented per second. So for example, if we had a sample rate of 60, that would mean that our frame will change 60 times every second. Or if we had a sample rate of 1, it would change just 1 time every second. And now we have a way of describing an animation, or an animation sequence, and we have our animator holding it. What else will our animator need? Well, we need some way of describing what the currently playing animation sequence is. So let's call that current, and it will be a string. It will be the sequence name that is currently playing, and current will index the sequences map. Now let's make a function that can create these animator objects, and we'll naturally call it new animator. New animator will take the container element, the element that this component is attached to, all of the sequences that it can play, And the animator needs to know which sequence it should play at the beginning before it's been told to play any other sequences. And we'll call this the default sequence. And this is just the name of the sequence that it will play at the beginning. And once again, this will index the sequences map. And it will return a animator. Okay, and then we'll just set the fields that we've been given. And we'll just set the current sequence to be the default sequence at the beginning here. And we'll return a pointer to the animator object that we've created. So we're seeing the beginnings of our animator component here. But if you recall, this isn't a component yet because it doesn't satisfy the component interface. A component has an onUpdate method, which is called every tick for physics operations or other non-drawing related operations. We have onDraw, where the component is supposed to draw to the screen, and onCollision, which handles whether or not an element should do something when it collides with another element. We won't be using onCollision for our animator because animators don't exist in 3D space or 2D space, and they don't collide with anything. But we still have to implement it because it's part of the interface. So let's start with onDraw, which to me has the most obvious use case here. We want the animator to draw the current animation frame on screen when onDraw is called. So if you recall, onDraw takes the renderer, which is used to draw things to the screen. Let's use the sprite renderer component we created in a previous episode as a point of reference for how we draw textures to the screen. You can see here that we get some information on the texture, namely its width and height. We convert the center point that we hold in the container to a top left point, which is what SDL uses as its point of reference for where textures are on the screen, and then use the renderer's copyEX method, which copies the image data and the texture onto the screen. So we're going to be doing the exact same thing here as we are in the animator, with just a few extra steps. So to me, that seems like a good a time as any to refactor this code out into a function that we can use both in the animator component and the sprite renderer component. So to do that, let's create a new file, and we're going to call it textureutils.go. Textureutils.go will just hold various functions that we use for textures, but for right now it will only hold this function, which let's call drawTexture. And let's just start by copying all of the code here in the sprite renderer's onDraw method. Okay, so this drawTexture function is going to need the texture it needs to draw. It's going to need some position information, some rotation information, and I think that that's it. So let's go ahead and add those as arguments. We'll start with the texture, which is again an SDL texture. We will provide the position information, which we store as a vector, the rotation information, which is just a floating point number, and we're also going to need the renderer because we use it to actually render the image onto the screen. So we will pass that in as well. And drawTexture doesn't have any output to return other than an error, in case there was a problem with drawing the image on screen. And then we'll just replace our references to the sprite renderer's texture to the texture we're passing in as an argument. Okay, and we have here a generic drawTexture function that we can use both in sprite render and in the animator. So let's just go ahead and refactor all this here to use this new function instead. So we'll just return the error, if any is created, from drawTexture directly. We'll provide the sprite renderer's texture. We will provide the sprite renderer's container element position. And same thing with its rotation. And the currently active renderer. Okay. And then we can use that for the animator too. So the animator's job is a little bit harder than the sprite renderer's. With the sprite renderer, we know which texture we're using. It's the texture that the sprite renderer is associated with. It doesn't have any other textures. But for Animator, we need to decide what the currently active texture is. What currently active frame in our animation do we want to display on screen? So we need to get the currently active sequence, the animation sequence that we're playing, and we need to get the currently active texture of that sequence, and then we can draw it to the screen. So let's start by giving the sequence object, or sequence type, a new method. And we're going to call this method texture. And all this method does is return the currently active texture of this sequence. So this is a relatively easy thing to do. We just need to index the textures list with the frame field. And that is the currently active texture. And refactoring that out into a method just allows us to have more sequence-specific implementation information in the sequence object instead of in the animator. So we can get the texture from the currently active sequence, which we will do by indexing the sequences map with our current field, which again keeps track of the currently active sequence. And then we will do the same thing we did in the sprite renderer, called draw texture with this texture, the animator's container element position, the animator's container element rotation, and the currently active renderer. So let's see, what have I done wrong here? Oh, I see. So I forgot to add the call to the new texture method that we created. There we go. So now we have onDraw basically finished. The animator will draw the currently active texture onto the screen. So refactoring this draw texture function out from the implementation that was previously available in the sprite renderer has a lot of nice benefits. For one thing, it reduces the amount of code that we have to write, and also it means that if I find any bugs in draw texture, I only have to change it in one place. Speaking of bugs, I just noticed this while creating this episode. Copy.ex returns an error in case there was an issue drawing it to the screen. But as you can see, I'm ignoring this error right now, which doesn't seem smart. So let's go ahead and fix that problem. So we'll go ahead and take the error from this call and check it. If error is not equal to nil, well, there was some issue with drawing the image to the screen. So let's just go ahead and return that error, but with some extra information. You know what? I'm not sure if we need to add this extra information because theoretically copy.ex should provide all the necessary context here for this error. So let's just go ahead and return it wholesale, which will save us a few lines of code as well for whatever that's worth. So now the animator is capable of drawing its currently active frame onto the screen, but there's still no code here to change the currently active frame to create the animation effect that we're looking for. So what would be the best place to put that implementation? Well, if you recall, a component has an onDraw and an onUpdate method, and really we could put it in either place, and you could justify either decision. But to me, even though changing the currently active frame is tangentially related to drawing the texture on screen, I see it as less of a drawing operation and more as a general piece of behavior for the animator component. So we're going to put it in onUpdate. And of course we needed to implement onUpdate anyway, so now we have a good use for it. So what do we need to implement here? Well, we need to add some kind of check that decides whether or not it's time to go to the next frame of the animation sequence. And we need to do it in such a way that it abides by the sample rate we've given the sequence, so the animation plays at the speed that we would expect. So how might we do that? Well, if we were to keep track of the last time that we changed the animation frame and then check to see if enough time has passed, then that could work, right? That could allow us to intelligently change the frame at the rate that we would expect. And so in order to do that, we need to keep track of that last time we changed the frame. So I'm going to add a new field to the animator called last frame change. And last frame change will be a time object. It'll be a timestamp of the last time we changed the frame. And so in here we can check to see if the time since the last frame change is greater than or equal to some value. We need to decide what the interval should be between frame changes in our animation. And we need to do it using the sample rate. But sample rate is it's sort of like an FPS, right? It's 60 or 30. it shouldn't be 60 or 30 seconds between frame changes. We need to use that information to calculate a duration. And we're going to do that by creating a new frame interval variable and taking a second and dividing it by the frame interval. So we need to get the currently active sequences frame interval. So let's just go ahead and create a new variable called sequence here. So we're going to get the currently active sequence, and we're going to divide a second by the sequence's sample rate. So what we're basically doing is, if the sample rate is, say, 60, then our frame interval should be a 60th of a second, right? There should be a 60th of a second between frame changes so that we change frames 60 times per second. And similarly, if the sample rate was 1, the frame interval would be 1 second, because we want to change the frame at 1 second intervals. And so as you can see, we get an error, and that's because time.sense returns a duration object. And under the covers, a duration is an integer value, an int64 to be specific, but our frame interval is a floating point object. So I'm just going to go ahead and create a duration from this frame interval here, so we don't have any type issues anymore. Okay, so now we know when we need to change the frame. So how do we do that? Well, let's add a new method to sequence called nextFrame. And this will take care of all of the logic necessary to move from one frame to the next. So what should our nextFrame method do? Well, at the most basic level, it needs to move from the current frame to the next one by incrementing the frame field. But what happens if we call nextFrame and we're already at the last frame of our animation? Should the animation loop by going back to the first frame of the animation and continuing forward that way? Or should the animation just end at the last frame? Well, the right answer here will depend on which animation we're talking about. When the basic enemy is flapping its wings in the idle animation, we want that animation to loop for, indefinitely, right? But for the destroy animation, we want that to play just once. We don't want the basic enemy to explode forever. We want it to explode and for that to be it. So we need an extra configuration field in our sequence object here, and we're going to call that field loop. So if this is set to true, we will do the first behavior, where we go back to the first frame when we're out of frames to play. And if it's false, we will just not increment the frame field anymore, and we'll just stay at the very last frame. So we're going to need some code here to check if we're at the last frame or not. So we're going to say if the current frame is equal to the size of our textures list here, -1, because of course slices are indexed at 0. So if that's true, then our behavior will depend on whether or not loop is true. So if loop is true, we will set the current frame to 0, and otherwise we will do nothing. And if we're not at the last frame of animation, we'll simply increment the frame. So then in our animator's onUpdate method, we just have to call the current active sequences nextFrame method, and since we've changed the frame, we need to update the last frame change timestamp to be the current time. And at the end here, we just need to return nil to say that no errors happened while we were updating the animator. Oh, and I forgot to mention that when we're creating a new animator object, we need to make sure to set the last frame change to something. And I think that we should set it to the current time, because effectively what we're doing here is when we create an animator, we're going to be on the very first frame of animation. So you can think of it like we are changing the frame of animation as soon as we create the animator. But more importantly, this means that the first frame will be displayed for the duration that we expect. It won't immediately go to the second frame like it would if we didn't set last frame change and this timestamp was 0, and it looked like it was an eternity since we changed frames. So now our animator component is looking pretty good. Let's see if we can use it in our basic enemy element. We want to replace the sprite renderer with our new animator component. So let's go ahead and get rid of this and create a new animator component. So new animator requires the container element, which will be basic enemy. And it also requires the animation sequences. So we need to be able to create these sequences here in new basic enemy. And we want to base it off of our directory of sprites here. So how do we do that? Well, let's create a new function, a constructor of sorts for sequence. And we will call it new sequence. I want this function to be able to create a sequence using a directory of image files. So the first argument here should be the file path to the directory that we want to create the sequence from. Then we have a few other configuration values here. We want to be able to set the sample rate, and we want to be able to choose whether or not the animation should loop. And then this will return a sequence object. So we want this function to be able to convert a directory of images to a list of SDL textures. And to do that, we're going to need to iterate over all of the files in these directories. And we will do that by using ioutil.readdir. ioutil.readdir takes a file path, which is the directory that we will be iterating over, and returns a list of os.fileinfo objects and an error in case there was any issue reading from this directory. So let's go ahead and check this error. And we can see that we're going to have to augment the return values of this function to include an error in case something happened. So let's see. If there was an issue reading this directory, we want to return nil because we weren't able to create the sequence, and we'll return the error with a little bit of added context. We'll say reading directory, and then we'll say which directory we were attempting to read, and the original error. Okay, great. So now we have this list of file info objects, so we can iterate over them. And create an SDL texture for each one. So how do we convert a bitmap image file to an SDL texture? Well, we've done it before in spriterenderer.go, so let's use that as a reference. So it looks like we start by calling sdl.loadbmp, which takes in the file name of the image we want to load and returns an image surface. Then we convert that surface to a texture using createTexture from surface. So we're going to have to be doing this again in two places. So it seems like a great opportunity to refactor this code out into a utility function. So let's go back to our textureutils.go file and define a new function called loadTexture from BMP. And we'll copy this logic here into the function body. So of course we're going to need the file name of the bitmap file that we're trying to load. And we're also going to need the renderer object because createTexture from surface is a method of renderer. So let's just go ahead and adjust this a little bit to not talk about the sprite renderer specifically anymore. And once we've created this texture, we'll just go ahead and return it. So this function is going to need to be able to return the SDL texture, it's a pointer, the SDL texture that we've created, and an error if anything happened. So right now you can see that we're panicking in case of errors, but we can do better than that. In case of an error while loading the bitmap file, we will return nil for the texture and this error, which we've already provided some good context for. Great, so now we have a generically useful loadTexture from BMP function. Let's refactor the sprite renderer just a little bit to use that. So we will assign the sprite renderer's texture field and an error to the result of loadTexture from BMP. And we'll provide it the file name and the currently active renderer. And then we just need to check that error. And you can see I've set this function up in such a way that it doesn't return errors and instead panics. I don't know if I can really stand behind that decision, but I'll stick with it for now in the interest of focusing on what we're talking about today, which is, of course, animation. Okay, so now that we've refactored this function out, we can use it in the animator as well. So, okay, load texture from BMP needs the file path that it loads from. And you might expect to be able to just use the file.name method from the file info object, but this actually just returns the base name. And when I say base name, I'm talking about 0.bmp, 1.bmp. It's the name of the file, but not its full path. So we need to go ahead and create the file path, or I should say the file name of this image, by concatenating the file path of all of the images and then the name of this specific image file. And I'm going to use path.join for this. And we're going to be joining the file path and the file's name. And then that we can use to load the bitmap file. So it looks like we're going to need the renderer object here, so I'm just going to add that to the list of arguments that new sequence needs. And then we just have to check this error. And then we'll just add some context, creating, or let's say loading sequence frame, and then the original error. And then we will append this newly created texture to our list of textures in this sequence. Oh, and we're going to actually need to create the sequence object. That's kind of an important detail. There we go. Okay, and then we just need to set a couple more configuration values that we've provided to new sequence, namely the sample rate and whether or not the animation should loop. And then we can return the result. Now we can use this in our basic enemy or new basic enemy function to create a map of sequences for all animations that the basic enemy can have. So we'll start with the idle sequence. So the idle sequence frames can be found under sprites. Let's see, it is sprites/basic enemy /idle. The sample rate for this animation is something that we're going to have to play with to see what looks the most right. So I'm just going to give it a value of 10 for now, and I'm sure we'll end up adjusting it. We do want this animation to loop, and we'll give it the currently active renderer. And new sequence returns an error, so we're going to have to check that. And so as you can see, I'm using the same lazy format as before where we panic when creating new elements. I guess I'll stick with that for the sake of consistency. But we'll still add some additional context to make this code a little bit less evil. Okay. And we'll do the same for creating the destroy sequence. And this is available under sprites/basic enemy /destroy. Again, we're going to have to play with the sample rate, so we're just going to set it to 10 for now. And we do not want this animation to loop. We only want the enemy to explode once. And again, we'll give it the currently active renderer. And we'll panic on error again. Okay, great. And now all we have to do is now construct that map. So the idle sequence is just going to be called idle. And we'll call the destroy sequence destroy. And we will provide that as an argument to new animator. And we want the default sequence of this basic enemy to be idle. We want it to start off just flapping its wings. We don't want it to be destroyed as soon as the enemy is created. That's the player's job, right? Okay, and then all we need to do is attach this new component to the basic enemy element. And as you can see, I forgot something. The animator is not a component yet because I haven't implemented the onCollision method. Now, onCollision is not very interesting for the animator because it doesn't exist in 2D space and can't collide with anything, but we need to define it anyway, so let's just go ahead and do that real quick. So we will just always return immediately here and not calculate any collisions. Okay, great. So let's give this a run and see what happens. All right, so as you can see, the enemies are flapping their wings, but it's a little bit fast if you ask me. So let's go ahead and adjust that a bit. Maybe instead of 10, let's try 5. Let's try it with it being half as fast. Okay, great. Well, I don't know about you, but this already is quite a bit more dynamic of a game than it used to be. But, of course, when we destroy an enemy, still nothing happens. Our animation isn't played. And that shouldn't be surprising because we haven't written any code to make that happen. So let's move on to that. Let's take a look at how we're destroying enemies with bullets right now. So in our new basic enemy function, we're attaching a vulnerable to bullets component to our basic enemy. And this vulnerable to bullets component implements the necessary behavior that we need to make bullets destroy the basic enemy. And it does that in the onCollision method by checking to see if what it collided with is a bullet and by setting the element's active value to false. So this doesn't give our animation any time to play, if it was even playing at all, because we're effectively immediately getting rid of the element just at the very moment that a bullet touches the basic enemy. What we really want is the vulnerable to bullets component to kick off that destroying animation, and we want to wait until that animation is finished before making the enemy disappear. So in order to do that, we're going to need the vulnerable to bullets component to interact with the basic enemy's animator component. And so vulnerable to bullets is going to have to hold a reference to that component. So let's create a new field in vulnerable to bullets called animator. And it will, of course, be of type animator. And in the constructor for this component, let's add some extra code that gets the animator component from the container element, which again is the basic enemy. And if you remember from an episode that feels a lifetime ago, we added a getComponent method where we can give it the type of the component we want, which in this case is animator, and getComponent returns just a component interface object, so we need to typecast it to a pointer to an animator object. But now we have a reference to the animator component that the basic enemy has, and we can use that in here to set its animation value, or set its current animation, I should say, to the destroy animation. And let's add a method to our animator to make that easier for other components to do. We'll add a new method called setSequence, and this will allow other components to set the animation sequence by name. So of course this means that we need to set the current sequence to the name given to us, and a little bit more subtly, we need to set the last frame change value to the current time. And this, sorry, I should say time.now. And this conceptually makes sense, right? When we change from one animation to another, we are effectively setting the current frame to the first frame of this new animation sequence. So it makes sense that we're going to have to set this last frame change value. Okay, and then in our vulnerable to bullets component, we simply call that method. Okay, let's try this out. So cool, it looks like our code is working. As you can see, the destroyed animation is playing when a bullet hits the basic enemy. But since there's no code to set the basic enemy's active state to false at any point in time, the basic enemy just hangs around forever after it's destroyed, and there's nothing we can do about it as a player. So effectively, we want the vulnerable to bullets component to do just a little bit more work. We want it to set the element's active value to false when this destroyed animation is finished. But how's the component supposed to know that? Well, we could have the component in its onUpdate method ask the animator component if it's finished or not, but we need to add some extra code to our animator here. So let's add a new field called finished. And finished here is a Boolean that is true if the animation is concluded and false otherwise. How would the animator know if the animation is concluded, though? Well, when the animator calls next frame, right now the sequence internally takes care of the case where we're out of frames and there's nothing more to play. But if we gave next frame the ability to indicate to its caller that the frame has, or I should say that the animation has concluded, then we would be able to do this. So let's have next frame return a bool. So I want next frame to return true when the animation has finished and false if it's still playing. And one thing to mention is that if a animation sequence is looping, it will effectively never finish. So this value will always be false, and that's okay for our use case. So let's add some extra code here to say if the sequence of animation has finished and the sequence is not set to loop, then we should return true to indicate that the animation is finished. And in all other cases, we want to return false. So now, over here, we can set the animator's finished value to the result of sequence.nextFrame. And then in the vulnerable to bullets component, we can check this value. And we're really only interested if the animation is finished, if the animator is currently playing the destroy animation. So in that case, if the destroy animation is finished, we want to set the element's active state to false. Let's try that out. All right, excellent. Look at that. So now our enemies are destroying like we'd expect. And I think that explosion animation is just a little bit too long. So let's go over back to our new basic enemy function here and adjust the rate here just to make it a little bit faster. Let's say 50% faster. Okay, that looks a lot better to me. And so now our game is quite a bit more dynamic. We've got some animation while the enemies are doing nothing, and some animation for when they're destroyed too, which I think makes for a much more fun gameplay experience. And, you know, we could consider adding animations to other things too. Like, for example, the player could tilt left and right when it's moving, and maybe have some fire that comes out the bottom of the ship at all times, you know, to show that the ship is moving forward along with the enemies. And I mean, you know, there's really any amount of things you can do with animation that help enrich your game. But now you know how to do it. And I think that'll be it for this episode. Thanks for watching.